This is A-level math paper 1 for 2013. Question 1. Given that f(x) equals to the cube of 2x minus 5 plus x, you need to show that f is an increasing function. If f is an increasing function, then it is necessary to show that its derivative must be positive. When the derivative of a function is positive, this indicates that the function is increasing. You are given f(x), so find its first derivative, f prime x here. For this function, you bring the 3 down. Then you have 2x minus 5, that is raised to the 2. Reduce the exponent by 1, and you still need to differentiate the inner function. 2x minus 5 has a derivative of 2, and for this last term here, x its derivative is 1. So that f prime x now is 6 times the square of 2x minus 5 plus 1. The square of any expression is always non-negative, and when you add to 1, that gives you a positive value. This indicates that f prime x is positive. So from here, f prime x is positive, and this implies that f is an increasing function. For question 2, you are given the expression 1 minus px that is raised to the 6, and p is a non-zero constant. You need to find the first 3 terms when the expression 1 minus px to the 6 is expanded in ascending powers of x. Now take note that the exponent is 6. This is actually a binomial expansion. Recall the binomial theorem, a plus b to the n, that is given by the sum of NCR, and you have a to the n minus r, b to the r. R starts from 0 and ends with n. So for this case, you have 1 minus px to the 6. This is actually 1 plus negative px to the 6, where b here, the second term of the binomial, is negative px. Applying the binomial theorem, you have 6c0, 1 to the 6, negative px to the 0 for the first term. The second term, you have 6c1, 1 to the 5, negative px to the 1. And the third term, you have 6c2, 1 to the 4, negative px to the 2. That gives you the first 3 terms. (6c0), that gives you a value of 1. 6c1 has a value of 6, and 6c2 has a value of 15. Then when you look at these parts here, anything raised to the 0 is 1. The first term has a value of 1. The second term has a value of negative 6px, and the third term is 15, p squared x squared. That gives you the first 3 terms of the expansion. That is for the first part here. Now for the second part, part 2, you are given that the coefficient of x squared is 0 in the expansion of this expression. Let's look at this expression. 1 minus x and 1 minus px to the 6. And you're given that the coefficient of x squared is 0. So we only concern ourselves with the x squared term and don't bother about the rest. 1 minus px, that is raised to the 6, was expanded in the first part here. So you replace 1 minus px to the 6 by whatever you have in part 1. That gives you 1 minus x, and you have 1 minus 6px plus 15 p squared x squared. We only need the x squared term. 1 times the third term gives you an x squared term, which is 15p squared x squared. And then negative x, to get an x squared term, you need to multiply with a term that contains x only, and that is 6px squared. So we have all these x squared terms. You are given that the coefficient of x squared is 0. Just delete the x squared. You have 15 p squared plus 6p. That is the coefficient of x squared, and it is 0. So you set this to 0 and solve for p. On the left side, you can factor out 3p, and you have 5p plus 2 equals 0. So either 3p is 0, which gives you p as 0, or 5p plus 2 is 0. Isolating p gives negative 2/5 here. From part 1, you are given that p is a non-zero constant. So this solution is not possible. This is inadmissible. And the only other solution that you have is 2/5 here. That will give you the final answer for question 2, part 2.